Sensors show plenty of water in the planet's atmosphere, enough to refuel our ship for 3 years.
Well, 3 years unless you start drinking out of the fuel tanks again.
But I get thirsty eating sun yums.
Sun yums.
Erwin, do you see that glowing sphere?
No.
Give me a close-up on the area where it collapsed.
Okie dokie.
It's the Compton cruiser. But something's wrong. Where'd it go?
Maybe it's playing hide and seek. Uh-oh. 3 unknown ships are hailing us and approaching at 14 speed units.
Put it on the view screen.
We are the Slowlians. You are trespassing in our space and must be punished. And don't bother pleading for mercy. The answer is no.
But we didn't ask a question.
Oh, well, when you do, the answer will be no.
Okay, can we not have all your planet's water?
Hold on. What exactly are you planning to do?
We will build our famous Slowlian web around you. Once completed, it will contract around your ship, sending it through a micro-wormhole into our alternate dimensional impound lot, where it will stay forever.
No!
Slowlians, initiate web creation.
They sure seem to be taking their time.
Well, at least it'll give us a chance to plan our next destination. Pull up the galactic map. This sphere represents the range of star systems we can reach with our current fuel. We've got to find some place in here with water in it.
None of these systems are mapped. How will we know which planets have water?
By analyzing the spectrum of their atmosphere. You know how you can break white light into a rainbow if you pass it through a prism? Well, if you make a graph of exactly how much light is coming at each color, that's what scientists call a spectrum. By analyzing the spectrum, you can tell what chemicals make up the thing the light came from in the first place.
That sounds like voodoo.
Actually, it's science. For instance, let me turn on the internal sensors.
It tickles.
Okay, now, according to the spectrum I just made of you, you are made of 90% heavy metals, 8% water, and 2% cheese?
I keep some in my pockets to put on my sun yums.
Sun yums go great with cheese.
Uh-huh. Well, anyway, astronomers can analyze light from planets the same way.
But aren't planets around other stars so tiny that we can't even see them from Earth?
A planet's light can get lost in a nearby star, that's for sure. But this is where the Spitzer space telescope is particularly handy. Infrared light is very good for finding planets, because planets actually do give off their own heat. So even though a star is much hotter than a planet, with infrared light, at least you have a chance of seeing it.
I see.
In fact, on February 21st, 2007, Spitzer scientists announced that for the first time, they were able to identify molecules in the atmosphere of a planet outside of our own solar system.
How could they do that?
I'll show you. Let's pick a star. This one.
Pitiful humans, are you enjoying your little predicament?
Okay, this is a representation of the planet HD 209458b, one of the first extrasolar planets we analyzed. By the way, how is that web coming?
Yeah, looks like we've got time. You were saying?
Right. Fortunately for us, the orbit of this planet takes it behind its star, at least from the viewpoint of Earth. So to begin with, Spitzer was able to detect infrared light from both the planet and the star.
So we would get a spectrum from this light that would tell us what the planet's made of?
It would tell us what the planet and its star together are made of.
So how do we find out about just the planet?
Good question. Watch this. Now that the planet has orbited behind its sun, Spitzer can take a second spectrum that tells us just what the star is made of.
But we want to know about the planet, not the star.
True. But if we were to subtract the second spectrum of the star from the first spectrum of the planet and the star,
We would be left with a spectrum of only the planet.
and that's what Spitzer has done many times since. Even when a planet is too small for us to resolve, Spitzer's been able to gather enough infrared light to determine what the planet is made of.
Oh, let me find one. This one's close by.
Now, we have to observe the planet over a good chunk of its orbit until it transits behind the star. This may take a while.
How much a while?
Days, months, years, maybe longer.
We can't wait that long. I'll activate a time suppression field.
What? Wait, Erwin.
See? By slowing down time for us, the rest of the universe speeds up relative to us. In moments, we'll have our spectrum data. Got it.
But if the rest of the universe is speeding up, so are the Slowlians, right?
Right. Uh-oh.
Erwin, go!
Ah! We're too late.
There's another gap.
Hang on.
We did it.
And by analyzing the spectra we recorded, I've learned that there is indeed a large amount of water on that planet.
So let's go fill up our fuel tanks.
Great idea. I'll need something to wash down my sun yums.
Now available in Cool Ranch.
Erwin!
I told you building a web was a dumb plan. Shut up, Daryl. Why don't you make me, Kevin? That does it. I'm going to build a web around you. Not if I build one around you first. I'm going to lunch.